we're now going to use the equations that we just learned, E equals h nu and E equals hc over lambda, to answer this particular question here. We're going to find the frequency, the energy per photon, and energy per mole of photons for green light. And green light has a wavelength of about 535 nanometers. First, we'll start with the frequency. So let's see, I want to find the frequency of green light. Well, we're going to actually have to use this equation, aren't we? We're going to have to remember that nu is c over lambda. And let's see, I'm going to write the frequency. That's going to be 3.0 times 10 to the 8 meter per second. And we're going to divide that by the wavelength. Now notice, my speed of light's in meters, and my wavelengths in nanometers. I've got to get these to talk to each other. In a previous video, we showed that the nanometer is 10 to the negative 9 meters, so we can just write that in. This meter cancels this meter, and my frequency unit is an inverse second, which is also known as a hertz. And we can do the math here. 3 times 10 to the 8th, that's the numerator. We're going to divide that by 535 times 10 to the 9th, make it negative. Wow, look at that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's right. So it's 5.6 times 10 to the 14 inverse seconds, which of course is the same thing as 5.6 times 10 to the 14 hertz. So I've calculated the frequency of green light. Now we want to find the energy per photon, and for that we're going to use this equation here. So I'll write that in. Energy is going to be Planck's constant, which is 6.626 times 10 to the negative 34 joules times seconds. That's H. We're going to multiply this by this frequency that we just found, which is 5.6 times 10 to the 14 inverse seconds. If I take these units here, joules times a second, and I multiply that by an inverse second, I see that an inverse second cancels this second unit when we multiply those together. And that means my energy unit that I'm going to be left with is the joule. Now we'll just do the math with the numbers. That's going to be 6.626 times 10 to the negative 34. And we're going to multiply that by 5.6 times 10 to the power of 14. That's going to stay positive. And that's going to be 3.71 times 10 to the negative 19 joules for every photon. So we've answered this question. Now we want to know the energy per mole of photons. Well, we're just going to multiply by a mole. So I have 3.71 times 10 to the negative 19 joules. That's for every photon. And of course, we know that there are 6.02 times 10 to the 23rd of anything in a mole. So there's going to be that many photons in a mole. Let's see, I've set this up. Photon cancels photon. And my unit are joules per mole, which is what I'm looking for. Energy per mole. So now I just got to do the numbers. 3.71 times 10 to the negative 19. I'm going to multiply that by 6.02 times 10 to the power of 23. That's 223,342 joules per mole. Or if I divide by 1,000 to get kilojoules per mole, we see that there are 223 kilojoules for every mole of green photons of green light.